Math 2, Semester 2, final review. We're starting with Unit 8. Did you guys say you wanted to see 1A, 1B, or both? Before I do either one, I'm going to have you guys take this packet, flip it over to the back. It should be empty on the back side. And we're going to write just a few things down, and these are things I suggest when you get your final, find some blank space on your final or the back of your bubble sheet and write these down, because most kids, when they have it written down and they get stuck, if they look at it, they can figure it out. Here's what we're going to write. Okay, x squared times x cubed versus x squared raised to the third. There's a 2, there's a 3, there's a 2, there's a 3, x, there's an x. What's the difference? Does anybody remember what we do here?
You add the exponents.
You add the exponents. Does everybody agree? Okay. On this one over here, what do we do? So it equals x to the what? X to the 6th. We multiply. And there's one other one. What if it was x to the 6th over x to the 2nd?
Subtract.
Okay, correct. It's tempting to do what? When you see the fraction and you see 6 and 2,
Divide.
it's tempting to divide. Should we divide? No, you should not. Think of it, you don't have to write this piece down, but think of it this way. How many x's do you have at the top?
6.
And how many at the bottom? How many sets reduce?
2.
2 sets, leaving behind how many x's?
4.
At the top, so it's x to the 4th. And we get that, is 6 divided by 2, 4? No, how do we get that?
Subtract.
You subtract. All right, so if you can remember when to add, when to subtract, when to multiply, write it down on your finals so when you get stuck you can look and it can help. All right, I'm not going to write it down here, but what do we do with negative exponents? Who remembers? Put it to the bottom. And what if it's already at the bottom?
Then you
You move it to the top. Okay, so I'm going to circle the negative exponents. There's one there, there, and there. Do you agree that x squared at the top is not negative? So it's going to stay put. Okay, so
Whoa.
okay, so we're going to do some moving. The x squared at the top is going to stay put, and what is going to join it?
X third and an X to the
Okay, so when it joins it, is it positive or does it stay negative? The whole moving makes it positive. Okay, x squared stayed, x cubed joined it. What about these two, Jaden? Can you tell us what these two are going to do since they're both negative?
Well, the 6 can be positive.
And the 6 is going to become positive, and that is going to become positive as well, but I have to do what with them? Swap them, switch them. Okay, so why, good, reciprocal. Why did the 6th? Good job. Why did the 4th? Why did the y's switch places but not the x's?
Because there is an X.
Okay, because both the y's were negative but only one of the x's. All right, so now I'm going to cover this. Look back on your back page. Does that look where we add,
X to the
multiply, or subtract? Add. So it's x to the 5th. Okay, I'm going to cover this. What does that one look like? What do we do?
Second.
Subtract. So why did are there more y's at the top or the bottom? Top. So it's going to stay at the top. Y to the 2nd. And that's it. You're done with that problem. Now, what you should be asking yourself after each problem is, can I handle this on my own on the day of the final? If you feel like, oh, I don't think so, put a little star by it, something, highlight it so that when you go back to study, and yes, you should study, you know which ones to focus on. Got it? Okay, next one. First thing I want to do, I'm going to cover this. Do you agree those are not like bases? There's nothing really to do except for the negative exponent. And I'll deal with the negatives at the end. I'm going to cover that B right there. Do you see where that power of 3 is on the outside? Okay, that's the first thing I have to do. Do you remember when we distributed exponents? We multiply the power. So that negative 2 times that 3 is going to be negative
6.
6. Now when I multiply, do I do negative 2 times 3?
Nope.
No, what power do I put here that I don't see?
3, 1.
A 1 and a 1 on the a as well. Okay, so a cubed is going to stay a cubed. B to the negative 7th, I'm not going to change just yet. Negative 2, whenever it's negative, I like to put in parentheses. Negative 2 raised to what power? What do you get when you multiply? Third. B to what power? What do you get when you multiply? I'm sorry, A. A to the third. And then B to what power when we multiply?
Negative 6.
Negative 6. And then outside, it's just B, but what's the power that I don't see?
1.
Okay. Now, I am going to move things around, and then we're going to decide what we want to do with the negatives. Let's address this first. What's negative 2 times negative 2 times negative 2? Negative 8. Negative 8, a cubed, b to the negative 7, a cubed, b to the negative 6, b to the first. Okay, you have choices. You can leave it the way it is and add, and if you're very comfortable with adding positive and negatives, or you can do what with all the negative exponents? Move them to the bottom. What do you want to do? Leave them like this and add the like terms, or I'm sorry, multiply the like bases, or do you want to make the negatives move to the bottom?
Let's leave it like this.
Move. Okay, I heard move first. I am going to move, but will you do me a favor? Will you leave it like this and add them and see if we end up with the same answer? Okay, here's the question I have for you guys when I move. When I move, will this negative 8 stay or move?
Stay.
It's gonna
Okay,
Stay.
it stays. Why does it stay if it's negative 8?
It's not a negative exponent.
Did you guys hear him?
No.
Say it one more time a little louder.
It's a negative coefficient, not a negative exponent.
Do you hear that? It's a negative coefficient to not a negative exponent. This is a negative exponent, it moves. Negative exponent, it moves. Is that there is positive, that there is positive, that there is positive. And this 8 does have an exponent. What is it? 1, and that 1 is not negative. So even though it's negative, it's not a negative exponent. Do you guys see that? Okay, so let's look at the A's. I'm going to do the A's first. Are any of the A's moving, or are they staying where they're at? So A3, A3. Okay, B's. These two B's are moving where? B7 and B6. And what about this B at the end? Staying at the top. Okay, now look at this one right here. What do I do? Multiply, add, or subtract?
You add.
Add. Right there. So it's negative 8a to what power? Does everybody agree it's to the 6th? Okay, B is just going to stay B to the 1 over, what do I do at the bottom? There's a B to the 7th and a B to the 6th. You add them and it's B to what power? Okay, now why would I get this wrong if I stopped here?
the B's can still reduce.
These can still reduce. Now 1 minus 13 is negative, or you do 13 minus 1 and know they're left over where? Bottom. Why? Is there more at the bottom to begin with?
Yes.
So when I reduce, will it stay at the bottom?
Yes.
Okay, so final answer is negative 8a to the 6th over what?
B to the 12.
B to the 12th. Jaden, did you get the same thing when you did it your way? Okay. So it doesn't matter, you pick the method you want, as long as you're doing your steps correctly, we will end up with the same answer. If you're feeling like, oh, there's too much, that's too hard, put a star by this one, a mark, a highlight. Somehow mark it so when you go back to study, you make sure you hit this one again. Questions? All right. Next one. This is a tricky one. Does anybody want me to do this one?
Yeah.
Yeah, I forgot.
There were two ways. There was the proper mathematical way, and then I gave you guys like a little shortcut, tricky way, not tricky, but a faster trick to know. Does anybody remember the trick?
No, I don't remember.
I multiply the 6 with one of these numbers,
The 3?
the 3. So 6 to the 2 over what?
18 over 18.
18, and then you reduce. So what is that? X to the 1 over 9, and that's it, because it said leave your answers in that form, in exponential form. Got it? Does anybody want to see the actual mathematical proper way?
No.
Just in case?
I'm good with the
Yeah,
shortcut.
if you're like, oh, I don't want to, then work on the next one. Okay,
I'm not
the
good next.
proper way, the 6th root of x to the 2/3 is, what's the power out here that I don't see? 1. Yes, I'm still going to add a 1 even though I already have a fraction inside. So it's x to the 2/3 raised to what power? 6 over 1 or 1 over 6? 1 over 6. And then what do I do with the power to a power? Multiply. 2 times 1 is 2. 3 times 6 is 18. Is that what we got? 2 over 18? Yes or no?
Yeah.
And then reduce it to 1 over 9. X to the 1/9. You pick the method. Shortcut or knowing your properties and how to work with them. All right. Are we good?
Yeah.
Okay. Next one. I'm going to start you off. I'm going to leave 6 to the 1/10 as 6 to the 1/10. But I'm going to change this to 6. Isaac, can you give me the power? 3/5 or 5/3?
3/5.
Does everybody agree with him? Yes or no? He is correct? All right. You guys finish it. Look at the back of the packet where I told you guys to write those rules down. What do you do when you're multiplying like bases? Are you giving me an answer or a question? Nothing?
I went to check. I went to check. I don't know what to do.
You don't know what to do next? Okay. What do we do? You add. So, but be careful. Do you multiply the 6 times 6 to get 36? No, you only add the exponents. The bases stay the... So it's going to be 6 to some power. What are you going to have to do first in order to add? Common.
Yeah, like say to common denominator.
There you go. Find a common denominator. Do that right now. 1/10 plus 3/5 on the side of your paper. Everybody should be working.
I got 6, 7, 10.
Did you guys already find a common denominator?
Yeah.
Ooh, you're fast. Is this 10 and this is... And this is 1/10, and you said that's what? So is 7/10 my answer? 36 to the 7/10 or 6?
6 to the 7, 10.
6 raised to the 7/10, and we leave it like this because that's the form it asked for. Questions? Okay. C. Before I go on to C, does anybody feel like, okay, I'm remembering it a little better now? I'm feeling a little better about the first few? Somewhat? Okay. Next one. Look back on the back. If you don't remember, what do we do with the exponents? Add, multiply, or subtract? Multiply. 1/3 times 2 over 1. You just multiply the numerators, multiply the denominators. What do you get?
2 or 3.
And I can't reduce that, so it stays x to the 2/3. So far, so good? Those of you that worked on it like I asked you to, did any of you get at least most or some of these correct so far? Yeah? Okay. Next section. Does anybody remember how to simplify these without a scientific calculator? Do you do the what? The radical?
Yeah.
Okay. Isaac, can you tell us what goes on the index and what goes as the power?
The index is 2,
Mm-hmm.
and that 3.
Does everybody agree with him? The denominator goes there, the index, the numerator goes as your power. Now, the order does not matter. If you wanted to, could you do 16 cubed first? Yes, but it's easier to do what first if you can? The radical, whether it's square root or cubed root or fourth root. Square root of 16, can we do that? Is that a perfect square root? What's the square root of 16?
4.
So my final answer is 4 or 4 to the third? 4 to the third, which you do have to simplify. 4 times 4 is 16. 16 times 4 is 64. Make sense? Okay. Now, look at the way I wrote it and the way they wrote it. I'm going to ask you, and I did address this when we did this unit, are these two things the same?
Yes.
I only heard one person answer.
Yeah.
They are. Does it matter where I put the exponent, inside or outside?
No.
No. which means, as I stated earlier, the order doesn't matter. You can do 27 times 27, get a big number, and break it down to a perfect cube. Or, if possible, do this first. Do the radical piece first. Is 27 a perfect cubed?
Yeah.
What times what times what is 27? Is it 3 times 3 times 3? So I end up with 3 to what power?
7.
Which is 9. Do you agree that's much easier than calculating 27 times 27 and breaking it all down?
Yeah.
Okay. Now, next one. There are no numbers anywhere, which means this number right here is not a 1, it's a what?
2.
2. Do you agree we always call those square roots? Is 18 a perfect squared?
Oh, wait.
Square root of 18 is not 9, right? Okay, what do we do with the 18 when it's not a perfect squared?
We do like this.
Break it down, the factor tree. Go ahead and do that now. And we take out our pairs. Jason, can you tell me what comes out?
3 and 3.
So the 3 this comes out as 9 or just 3?
3.
And radical, what stays in?
2.
2. Good job. All right. Questions? Okay. I'm going to have you guys try number 4 quickly on your own, best you can. If you don't remember the definitions, take an educated guess. An educated guess is not eeny, meeny, miny, mo. What do I remember about real numbers? What do I remember about rational numbers, irrational?
I don't remember any of this. But
You said the same thing earlier, and you were giving me the answers earlier. So
okay,
obviously,
like
Does
yeah,
it keep coming back?
pretty much.
okay. Are we ready? Okay. Gentlemen. Okay.
False true, false true.
Okay.
Yes.
For us right now, real numbers are everything except for complex numbers which have the eyes. Do any of these have eyes? The imaginaries? No.
Okay.
Or square root of a negative. Do any of these have a square root of a negative?
No.
So, are they all real numbers?
Yes.
Yes, they are. True.
True, false, false, true.
It's true because there's no imaginary numbers here. Got it? Okay. Are they all rational? Does anybody remember what a rational number is?
That isn't the, doesn't have a decimal. Right?
It can have a decimal as long as the decimal
Over.
it can go on forever as long as it repeats. So 0.333333 or 0.252525. So decimals that go on forever and do not repeat
And never
are not rational.
four and
Okay,
third.
so I'm going to put a note here. Rational is a number that can be written as P over Q. That's why we had it in our notes. P over Q are integers, positive or negative whole numbers. 1 over 5, negative 2 over 3, 5 over 1, negative 5 over 1. Those are all rational numbers. What about the square root of 25? Is that rational or irrational?
Irrational.
Listen to it again. Square root of 25.
Oh, rational.
Why? Because square root of 25 is?
5,
And 5 can be written as 5 over
2, 1.
1. What about the square root of 36?
Rational.
Because it's 6 over 1. Okay, what about 7?
No.
Not square root of 7, just 7.
It's irrational. It's rational.
Rational because it's 7 over 1. So is
No.
any whole number going to be rational?
Oh, yeah.
Yes, because you can write it over 1.
Oh.
Any integer, positive, negative numbers are rational because you can write it over 1.
So what's irrational?
So irrational is something like the square root of 5. Is 5 a perfect square?
No.
Square root of 7.
With a 1, right?
What is that?
With a 1? Over 1?
Oh, right. But it doesn't matter. Something like the square root of 5, the square root of 7, the square root of 12.
Oh, it's the square root.
Yeah, all of those are irrational.
Gotcha.
Right, because we could still write it over 1, but the tops and the bottoms have to be integers. And root 5, when you take the square root, is not an integer. It's a long decimal that goes on forever and never repeats.
So
Yes.
What is the square root of 25?
The square root of 25 is rational because it equals 5, which is 5 over 1. So if the radical is a perfect square, where would it fall?
Rational.
Rational. If the radical is not a perfect square, where would it fall? Irrational. Okay, so let's come back here. All the numbers are rational.
True, false, false, true.
What is letter B true or false?
False.
Okay, next one. All the numbers are rational.
True.
True. We just talked about that one. That one is true. Hello, Mrs. Torres.
True, false, true, false. I knew it.
Where are our seats today? I don't know. No.
Is it for me?
Nope.
Dang.
Okay. Next one. All the numbers are integers. Integers are positive and negative whole numbers. 5, -5, 3, -3. No fractions, no decimals.
True.
So all of these are integers, yes or no?
Wait, hold up. No. Yeah. Nah, it's true, false.
Okay, integers are no decimals. If I take the square root of 11, am I going to end up with a decimal?
No,
Yes.
It's false.
Maybe.
It's true?
Let's check. Square root of 11, second square root 11. Whole number or decimal?
Yes.
That's a
Okay,
decimal.
that's not, and integers are no decimals.
It's not repeating 3, 3, 3, 3.
Okay, but now we're talking about integers.
What
So
is that?
integers have no decimals or fractions at all. Whole numbers, positive, negative.
So it's false.
False.
See that? I called it. True, false.
He called it.
Dude.
When we started, you said false, true, false.
Nope, I don't recall.
Okay, guys, we're moving on.
She's recording this. We can have
Okay. We're
Whoa.
we're moving on. Next section. Okay. I want you guys, I'm just going to give you a few seconds to quickly do as many of these as you can. A, B, C, D, E. Just go through and do really quick. This is multiplying, so you're multiplying. Same thing here. Here you're dividing. Letter D. Is this double distribution, yes or no?
No.
Because there's what right here?
The plus.
Okay, who remembers?
So
If
you
there's
just add the 8 and 5?
if there's nothing to distribute, what do I do with the parentheses? Drop the parentheses and then add the 8 and the 5 and the root 3 with root 3. Here,
Here's the stage, right?
gentlemen, here, what do we do first before dropping the parentheses?
Subtract.
Multiply by
Distribute.
1.
Distribute the negative only to the term on the right. Okay, go ahead and work them out. Get to work.
I'm so confused already. I don't know this one.
Do the best you can. At least these two. We just talked about these two right now.
Okay, so you add the 8 and 5, right? But you leave the
What's 1x plus 1x?
1x.
No, 1x,
2x.
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 It's okay. So what's root 3 plus root 3? Or what's 1 root 3 plus 1 root 3? 2 root 3.
Where do you get the 1 from?
There's, I don't put them out anymore because too many ended up missing.
But I thought it was the...
You make it sound like it's my fault. I don't know. I don't know.
On the test?
Calculators. Christmas.
No.
Okay. Shh. Isaac, you should be working.
I don't know what to do. But it's raining.
Isaac,
My bad.
you just asked me about that one. I said
still
yes.
don't get it.
You
Okay.
gave me the answer verbally. You just have to write it down.
So you have to put the plus on it? Okay. What? Talking all that rah-rah. Hey, let me get the
All right. Stop the talking.
Can you do C?
I will. Just try what you can on your own. See, you divide. 6
did.
divide by 3. Root 45 divide by root 5.
Live.
when you're multiplying. All right, I'm going to give answers, and you're going to tell me if you need to see them, yes or no. 5A is negative 10 root 21. How'd you guys do?
I do got that right.
Good. Good. Negative 210 for B. Anybody get that one?
No. Can I see it?
1, 2, yeah.
Wait.
2 people.
Wait, what?
That's making me sound
Okay, C is 6.
just
Just 6. Anybody get that one?
How do you do that?
I'm going to go over them. 5D is 13 plus 2 root 3.
I got that one.
And you got that one?
Oh, I did.
Okay. Next one is 2 minus what? 7 root 3. You know why? You added the 9 and 2, but one was positive and one was negative.
Oh,
It was negative 9 and positive 2.
wait, why 3 and not 13?
Wait, why is it
Yeah.
Why 3 and not what? Oh, sorry. That should be a 13.
Also trying to figure out how you got negative 210.
Okay.
I still.
She's gonna go over.
Okay. Guys, do we need A, yes or no? We're good on A?
No, that one's easy.
5 times negative 2 is negative 10. 3 times 7 is root 21. 21 doesn't break down. You're done. Okay, next one we treat the same way. Please stop the talking. What's negative 5 times positive 7? Negative
Negative 35.
times. What's root 12 times root 3? Root
36.
is 36 a perfect squared? Yes. What is the square root of 36? Not root 6, just 6, right? So then you do negative 35 times 6. Do it by hand, do it in your head, plug it in your calculator. What's negative 35 times 6?
Miss Flores,
Yes.
where did you get 35?
Negative 5 times positive 7. Right there.
Jingle bells.
Okay. Next one, does that make sense, guys?
Yeah, I got it.
So next one is very similar, but we're dividing. There's no exponents here, so I'm not subtracting anything. I'm just going to divide. What's 6 divided by 3? Times the square root of what's root, because they're both in a radical, you can reduce it. What's root 45 divided by root 5?
That's 9.
9. I'm going to really quick pretend it's 7. If it were 7, is there anything else I could do? No, but it wasn't 7, it was what?
9.
Now, if I stop here, would I be wrong?
Yeah.
Because root 9 is a perfect cube, a perfect square, sorry. So I end up with 2 times, which is 6. Okay. Anybody feel like I didn't get it, but now that you've done it, it makes a little more sense? Good.
That's crazy.
Again, if you feel like, I don't think I can do this on my own, star it, highlight it, come back and study it. Yes, yes.
How did you do C? I'm completely lost.
Uh-huh. 6 divided by 3 is 2.
Okay.
45 divided by 5 is 9, but the radical is still there. Root 45 divided by root 5 is root 9. Root 9 is, it's a perfect square. So square root of 9 is 3.
All right, now I see it.
You got it? And the radical's gone, so it's 2 times 3 is 6. Okay. These two here.
These ones are easy.
Do we need these, yes or no?
Nah.
Which one?
D and E.
No, I'm good.
We're good? Okay. Do you want both, or do you care which one?
They're
I
easy.
just have a question, like, how come for D you have 2, but then it's like for E you didn't?
Okay. Let me show it then. So drop the parentheses because there's nothing to distribute. What's 8 plus 5? Those are my like terms. Now, next piece. Do you agree that's a 1 root 3 and a 1 root 3?
Yeah.
Yes? What's 1x plus 1x, or x plus x?
It's 2x.
2x. So what's 1 root 3 plus 1 root 3?
2 root 3.
Does it need the ones in the front for you to know that it's going to be 2 root 3? No, you don't have to write them, but you can if it helps you visually to see it. Or if you can just do it in your brain, root 3 plus root 3 is 2 root 3, you're good. Root 3 is not a perfect square, so we leave it like this. Got it?
Yeah.
Okay, good.
I get
Next
this.
one.
I got you.
Good. So do you want to see the next one, Wendy? You're good? I'm just going to at least write it out. Do you guys agree you would have to distribute? So when you combine your like terms, 7 and negative 5, negative 9 and positive 2. Got it?
Oh.
So do you see why it wasn't that 11 or whatever that was?
It's the one's negative. and
Yeah,
it's positive.
that one's negative, that one's positive. Okay, are we good?
Yeah. For
6.
you get 18 9 over 4.
18, 9 over 4? What?
Did you get that for A?
Oh, this one's 9, and this one is 12. Did anybody get that? 6A, 6B?
Same thing.
Yeah. Anybody get 9? And then 12, those of you that worked ahead?
Alright, yeah.
Okay. Before I go over B, does anybody need to see letter A? Or would like to see letter A?
No, it's light word.
Yes.
Yeah? Isaac, can you explain what you did?
Alright.
Guys, let's stop the talking, please. I'm ready.
So like, I did 18 3 over 4 times 18 6 over 4.
And I'm going to pause you there. Can you tell me how you knew, like what in this big problem, looking at the whole thing, what prompted you to rewrite these in exponential form?
Easier though.
It's easier that way? It's correct. And is this one over here in exponential form?
Yeah.
And what can I do at this point? Once it's in exponential form, go ahead, Isaac.
Add the numerator.
Add the exponents?
Yeah.
Was that what you were going to say? At the numerators. Okay. So 3 plus 6 is, I need a common denominator. Are they already common?
Yeah.
So what does that give me?
9 over 4.
And I want it to equal 18 raised to the x over 4. Everything's the same. The bases, the denominator. What does x have to be in order for it to be equal?
9.
9. Okay. Now, Ethan, I'm going to have you help me with the next one. What would you, did you hear when Isaac explained this one? He said change them both to this form, exponential form, so that we could add the exponents. I want to do the same thing here, so which one will I change? Numerator and denominator, or just the numerator? Oh, hold on, I'm asking Ethan. Just the numerator. So I'm going to do that. 7 to the 5/12 raised, or over, 7 to the 1/3.
You need to get a common denominator.
Okay, common denominator is correct, and Ethan, coming back to you. Can you tell me what to do with these exponents? Add, multiply, or subtract? Everybody hear him? Subtract. Jason, can you tell us why we're going to subtract?
Because of the line.
Fraction?
Yeah.
Because it's a fraction and we subtract? Thank you.
Yeah, ma'am.
Okay. So, what do I have? 5/12 take away 1/3. I want you guys to do that now. What's your common denominator going to be? 12. Can you guys go ahead and do that now?
Wait. What did you do? I got the same answer, but I did differently.
Okay. Are you ready?
I don't get your way.
So, subtract. What do we get? What's my top number right there? 4. So that gives me 1/12.
Yeah.
So 7 to the 1/12 equals 7 to the 1 over x. What does x equal? 12. Yes.
You did it weird.
Did you, knowing you were looking for just the denominator, did you just,
Yeah, because the 12 is a bigger number, so I multiplied 3 times 4 and then 1 times 4.
that's fine. The only thing you would want to be careful with is what if this didn't come out to be 1/12, it came out to be something else and you had to reduce it?
But it gave it to you. So
I know,
that's
I know,
fine.
I know. I said what if, not it did on
But
this
it
one.
is.
Okay, so we're good?
Yeah.
Yeah.
All right, let's flip the page.
What the heck? I don't know.
Okay. I am going to save this one for tomorrow because it is a long one and I won't have time right now to go over it. So I'm going to go over number 8. The rest, hopefully, you can do on your own. I will continue going over this tomorrow. And what is tonight's assignment? 10 and 11. 10 and 11. 10 and 11 are already combined together. Let's see.
Gnarly.
There it is, 10 and 11. Does everybody see that? Okay. There is one correction we do need to make. Can I have everybody listening?
What number?
Unit 9. Can everybody go to Unit 9?
Number J.
Unit 9. Everybody there? Number 6, which is on the next page. So click over to this page here. Does everybody see it? It's right there.
I don't see a number 6.
Unit, you have to flip over a few pages because of all the A, B, C, D, elemental P.
Oh,
Okay.
the trinomial one?
Yes, the trinomial one. Does everybody see it? Okay. That minus sign right there should be a plus. 3x squared. It's not going to work otherwise, at least not with the numbers they've given you here. Plus 15. Can you guys please make that change? This minus sign should be a
What?
plus. Sorry. Yeah, if you tried it on your own, you're like, why is it not working? My apologies. That should be a plus. Now, let's flip back over to the Unit 8. Everybody make the change?
Yup.
Helva, did you make the change?
Yep.
Okay.
Letters.
Let's flip. I know. Let's flip over to this one here.
Can we do J? It looks like a lot of work.
Which word?
Oh, on the first page of Unit 9.
Well, no, I'm still on Unit 8. Okay. Now, I want to simplify this the same way we did on the previous page. Here's a big mistake kids make. They'll say that this, there's different ways of doing this. They'll say that this is 2x raised to the 2/4. Can everybody see why that is wrong? Or can anybody see why that is wrong?
Because there's an X.
Okay. Did I do this part correctly? 2 over 4.
Yeah.
Okay. Did I do this part correctly, leaving it as 2?
No.
No. What's the little power here that I don't see?
You don't see the
1. So it's 2 to the what? 1 over 4. Do you guys see how that works?
No, I don't get it.
2 to the 1/4, x to the 2/4. Everything here is underneath the radical, so it all gets the 4th root part attached to it. So this one's going to be the same thing. 2 to what power? 2 to the 1 over 4? Yes or no? X to the what?
X to the...
I'm right here.
3/4.
3/4. Let's add or multiply like bases. 2 to the 1/4 times 2 to the 1/4 times x to the 2/4 times x to the 3/4. Add your exponents. Leave your bases the same. The 2 is going to stay 2. What's 1/4 plus 1/4? You only add the tops as long as the bottoms are the same. 1/4 plus 1/4.
That's 2/4.
2/4. Does 2/4 reduce?
Yeah, the 1/2.
2 to the 1/2.
The answer is A.
Okay, x to the, what's 2/4 plus 3/4?
I can't see.
We're adding right here. Is it 5/4? X to the 5/4. Does that reduce?
Nah.
Okay, is there anything that looks like this or closest to this?
A.
Mm,
C. Oh, wait, no, it's D. It's
Oh.
B. It's just not reduced.
it's just not reduced. I'm glad that one came up. Right here, so is it this one here? Now, I reduce out of habit, and should we be doing that on a regular basis? Yes, but
I mean,
if they have it where it's not reduced, don't freak out. It's the same thing. Is this right here the answer? B.
no.
Make sense? It could be, yes. It could be like that where it's not reduced even though we reduce. Questions?
No.
All right.